Look up tonight, if the city lets you. Find a dark field, lie back on the cold ground, and let your eyes adjust until the faint stars come out of hiding. And then I want you to do something that sounds simple, but almost nobody actually does. I want you to stop thinking of those points of light as decoration. They are not the ceiling of the world. They are not a painted dome hung over your head for your comfort. Every one of those pinpricks is a sun, a furnace, a thing so large that our own sun, which can burn your skin from 93 million miles away, is an unremarkable member of the crowd. And here is the thing I came here to say, the thing that took the human species 4,000 years of staring at that sky to admit. Almost every one of those suns has worlds going around it. Planets. And we have spent most of our history assuming those worlds were empty, dead, irrelevant, or non-existent. We were wrong. We were spectacularly, embarrassingly wrong. And I want to tell you exactly how we found out, and why it changes everything about the question you have been secretly asking since you were a child. The question you were maybe told was childish. Is there anybody else out there? Now, I know what some of you are thinking. You are thinking, we already know the answer is probably yes. The galaxy is huge. Of course there is life somewhere. And I want to stop you right there. Because that easy confidence is exactly the kind of thinking I have spent my whole life trying to talk people out of. Not because it is wrong, necessarily, but because it is lazy. It is a feeling dressed up as a fact. And a feeling is not evidence. For most of human history, the belief in other worlds was pure philosophy, pure poetry, pure guesswork. Beautiful guesswork, sometimes. But you could not weigh it. You could not measure it. You could not put it in front of a skeptic and say, "Here, look through this, see for yourself." And I am a skeptic. I am proudly, professionally a skeptic. I have spent decades telling people that extraordinary claims require extraordinary evidence, that the fact that you want something to be true is the single most dangerous reason to believe it. So when I tell you that the search for another Earth has moved out of poetry and into the domain of hard measurement, out of the seminar room and into the observatory, I want you to understand that this is not me getting swept up. This is the most disciplined thing I know how to say. So let us do this properly. Let us build it from the ground, brick by brick, and I promise not to skip a single step, because the moment somebody skips a step is the moment they slip a lie past you. Start here. What is a planet, really? Not the dictionary answer, the physical answer. A planet is a body that formed not out of some special cosmic favoritism, but out of leftovers. When a star is born, it condenses out of a vast, cold cloud of gas and dust, collapsing under its own gravity, spinning faster as it shrinks, the way a figure skater spins faster when she pulls in her arms. And that spin flattens the leftover material into a disk of debris orbiting the newborn star. And in that disk, dust grains bump into dust grains and stick and grow into pebbles, and the pebbles into boulders, and the boulders into worlds. This is not a rare miracle. This is what leftover matter does when you give it gravity in a few million years. It is, frankly, almost inevitable, which raises a devastating question that people somehow avoided asking for centuries. If this is just what happens around a young star, and if the sky is full of stars, then why on earth did we ever think our solar system was special? Why did we assume the planets we could see were the only planets there were? I will tell you why. Because we could not see the others. And in science, and in life, there is a permanent temptation to confuse "I cannot see it" with "it is not there." This is the great trap. The absence of evidence gets quietly promoted, when nobody is watching, into evidence of absence. And for a long time, the sky handed us a beautiful excuse to fall into that trap, because finding a planet around another star is one of the hardest things human beings have ever tried to do. Let me make you feel how hard. Here is where it gets strange. And I want you to really sit with this. Picture a lighthouse on a distant shore, its lamp blazing, and picture a single moth fluttering right next to that lamp. Now back away. Back away so far that the lighthouse is just a dot. The moth, of course, vanished long ago. That is the problem, but I have made it far too easy on you. Because a star is not a million times brighter than its planet. A star like our sun is roughly 10 billion times brighter than an Earth beside it. 10 billion. And that planet is not a comfortable distance from the star. It is jammed right up against it from our point of view, separated by an angle so small it is like trying to spot that moth against the lamp from the other side of a continent. For most of the 20th century, the honest astronomer had to admit, we have no way to do this. The planet's own feeble light is drowned, utterly, hopelessly drowned. So the pioneers did something clever, something I love, because it is the essence of how science actually gets done when the direct route is blocked. They stopped trying to see the planet at all. Think about what a planet does to its star. We say the planet orbits the star, and that is true enough for a school book. But it is not the whole truth. And the whole truth is where the good physics lives. The star does not sit perfectly still while the planet circles it like an obedient dog around a fence post. No. They both orbit their common center of mass. The planet, being small, swings around in a big circle. The star, being enormous, barely moves. It just wobbles, a tiny circle, a little drunken stagger, tugged first this way and then that by the gravity of a companion it cannot shake. And here's the beautiful part. When that star wobbles toward you, the light it sends you gets squeezed, shifted ever so slightly toward the blue. When it wobbles away, the light stretches, shifting toward the red. This is the Doppler effect. The same reason an ambulance siren drops in pitch as it screams past you, except now it is written into starlight, so you cannot see the planet. Fine. But you can watch the star's light shiver, blue and red and blue and red, in a perfect rhythm, and that rhythm is the fingerprint of an unseen world reaching out and yanking on its sun. You are detecting a planet you will never see, by measuring a wobble too small to watch, encoded in a color shift too subtle for any eye. That is not stargazing. That is detective work of the highest order. Now, I lived through this. I want to be honest with you about my own history here, because I think the honest version is more interesting than the triumphant one. For most of my working life, this was all still theory. We had our own solar system, 8 or 9 worlds depending on your mood about Pluto. And beyond that, nothing confirmed. Nothing. I would give lectures, I would write, I would talk about the possibility of other worlds. And there was always, quietly, in the back of my mind, a cold little voice that said, "But you do not actually know." Not one. You have never confirmed a single planet beyond this sun. Everything you say about other worlds, everything, rests on the assumption that our sun is not unique. And that assumption might be wrong. It kept me humble. It should have kept everybody humble. Because it is entirely possible to build a magnificent tower of reasoning on a foundation you have never checked, and the universe does not care how beautiful your tower is. And then, near the end, the foundation got checked. In the early 1990s, astronomers found planets in the last place anybody expected, whipping around the corpse of a dead star, a pulsar, the collapsed cinder left behind by a supernova. Strange, hostile, irradiated worlds, orbiting a lighthouse of death that spins hundreds of times a second. Not where you would look for a cousin of Earth, but planets. Real, confirmed, weigh them and map them planets, outside our solar system. The dam had a crack in it. And then, in 1995, the dam broke. 2 astronomers in Switzerland, Michel Mayer and Didier Queloz, watching a perfectly ordinary sun-like star called 51 Pegasi, saw the wobble. They saw the star lean toward us and away, toward and away, in a rhythm. And when they worked out what kind of world could be pulling on it that hard and that fast, they got an answer that was, frankly, insane. A planet as massive as Jupiter, but orbiting its star closer than Mercury orbits ours, screaming around its sun in 4 days. 4 days. A year on that world is shorter than a work week. A gas giant so close to its star that its outer layers must be boiling off into space. And here is where it gets strange, truly strange, because that discovery did not just add a planet to the list. It broke the theory. Every model we had of how planets form said you cannot put a Jupiter there. Giant planets form far out in the cold, where there is enough ice and gas to build something huge. They are not supposed to be roasting right next to the fire. The experts, the serious people, looked at 51 Pegasi b, and many of them said, "This must be a mistake. This must be some pulsation of the star itself. This cannot be a planet, because a planet cannot be there." And they were wrong. It was there. And what that taught us, what it beat into us, was a lesson I want you to carry out of this room. The universe is not obligated to match our expectations. It is not even obligated to be reasonable by our standards. The other solar systems out there are not tidy copies of ours. They are wild, they are varied, they are full of things our textbooks forbade. And every single one of those forbidden things is a gift, because it tells us our imagination was too small. I have to pause here and tell you something personal, because it matters to me. I did not get to see most of what came next. My time was nearly up when 51 Pegasi planet was announced. I got to stand at the doorway. I got to see the very first confirmed world around a sun-like star, and then the great flood of discovery came after me, and I would have given a great deal to see it. So when I tell you what we know now, understand that a good part of it is me telling you what my colleagues and my students and the people who came after built on top of that first crack in the dam. I am not too proud to say that. That is how science works. It is a relay race run across generations, and no runner finishes the course. You run your leg as hard as you can, you hand off the baton, and you trust the ones behind you to run faster than you did. They did. They ran faster than I ever dreamed, because the next move was the one that turned a curiosity into a science. It is one thing to find a planet here and a planet there. It is another thing entirely to take a census. To ask not is there another world, but how common are worlds, and worlds like ours in particular. And to answer that, they built a telescope, and they did something that requires an almost inhuman patience. They pointed it at a single patch of sky, a modest patch, up near the constellation Cygnus, and they held it there, steady, for years, staring at more than 150,000 stars at once, and doing one thing, measuring their brightness, over and over and over, with fanatical precision, waiting for a shadow. Because this is the second great trick, and it is even more elegant than the wobble. If a planet's orbit happens to be lined up just right, edge on to us, then once every orbit that planet will pass directly between us and its star. It will transit. And when it does, it blocks a tiny sliver of the star's light. The star dims, just slightly, just for a few hours, and then brightens back to normal. A little dip. If you saw one dip, you would think nothing of it. Stars flicker for all sorts of reasons. But if you see that exact same depth, repeating on a perfect schedule, every 50 days, every 200 days, every year, then you are watching a world pass in front of its sun, throwing its shadow across the light years to fall, at last, on your detector. And from the depth of that dip, you can measure how big the planet is. From the timing, how far out it orbits. You have never seen it. You have only watched a star get faintly, rhythmically dimmer. And from that whisper, you have weighed and sized a world. Now here is the payoff. And I want you to brace yourself. Because when the census came back, it rearranged the furniture in every thoughtful person's head. That telescope, staring at its patch of sky, found planets everywhere. Not occasionally. Everywhere. And when the statisticians corrected for all the planets we must be missing, all the ones whose orbits are not lined up edge-on, all the small ones hiding in the noise, they arrived at a number that I still find staggering to say out loud. Planets are not rare. Planets are the rule. On average, most stars have planets. There are, at a careful and conservative estimate, more planets in our galaxy than there are stars. Hundreds of billions of worlds. In this one galaxy. And there are hundreds of billions of galaxies. The arithmetic runs away from you. It should run away from you. We went, in a single human lifetime, from not knowing whether a single other planet existed, to knowing that the universe is drowning in them. That is one of the great transformations in the history of thought, and most people slept through it. So let me demolish the next comfortable assumption, because you are getting comfortable again. I can feel it. You are thinking, wonderful, worlds everywhere. So surely some of them are like Earth. Surely we are close to finding home away from home. Slow down. Because the phrase Earth 2.0 is doing an enormous amount of dishonest work, and I will not let it slide. What do we actually mean by another Earth? A planet the same size as ours? That is easy? We have found many. A planet the same distance from a sun-like star, So it is neither frozen nor roasted? Harder, but we are getting there. This is what people call the habitable zone, sometimes the Goldilocks zone, that band of distances around a star where it is not too hot and not too cold, where water could sit on the surface as a liquid instead of boiling away or freezing solid. And water matters. Not because life must use water, we do not know that, but because water is a superb solvent, a place where the delicate chemistry of life can happen, and it is our one and only example. So we look for worlds the right size, in the right zone, around the right kind of star. And when we find one, the headlines scream, Earth's twin discovered. And here is where it gets strange, and a little frightening, because being in the habitable zone is not remotely the same as being habitable. Let me prove it to you without leaving our own solar system. Come home for a moment. Look at our two neighbors, the two worlds that sit on either side of us, just inside and just outside that comfortable Goldilocks band. Look at Venus. Venus is almost Earth's twin by the crude measures. Nearly the same size, nearly the same mass, made of nearly the same stuff, and it sits close to the inner edge of the habitable zone. By the headline logic, Venus should be a paradise. Venus is hell. I mean that almost literally. The surface of Venus is hot enough to melt lead, hotter than a kitchen oven set as high as it will go, and then some. The air is a crushing ocean of carbon dioxide, 90 times the pressure you feel right now, and the clouds are not water. They are sulfuric acid. A human being on the surface of Venus would be simultaneously crushed, roasted, and dissolved, and I am not sure in which order. I know Venus better than I know almost anything, because I spent a good part of my life on it, in a manner of speaking. As a young man, I worked on the question of why Venus is so hot, and the answer that we hammered out and that turned out to be correct, is the runaway greenhouse effect. Venus trapped its own heat. Carbon dioxide in its atmosphere let sunlight in but would not let the heat back out, and the temperature climbed, and the rising heat drove more gas into the air, which trapped more heat. A vicious spiral with no bottom, until the oceans that Venus may once have had boiled entirely away into the sky. That is a world in the habitable zone. That is what habitable zone gets you if the rest of the details go wrong. And I will tell you plainly that work on Venus is a large part of why I spent the later years of my life shouting warnings about what we are doing to the atmosphere of our own planet, because I had seen, up close, what a runaway greenhouse looks like, and I did not want to see it here. And then look the other way. Look at Mars, just outside the zone, or right at its cold edge. Mars is small. And because it is small, its gravity is weak, and it could not hold onto a thick atmosphere, and it could not hold onto its heat, and over billions of years it leaked its air into space and froze. There is evidence written all over its surface that Mars once had rivers, lakes, maybe an ocean. Liquid water, flowing long ago. And now it is a frozen desert with an atmosphere so thin your blood would boil in it. So there is your lesson, and you did not have to leave home to learn it. Two worlds, both near the habitable zone, both roughly Earth-sized in the case of Venus, and one is a crushed inferno, and the other is a frozen tomb, and only the little rock in the middle came out alive. Habitability is not a location. Habitability is a knife edge. It depends on the size of the world, the composition of its air, its magnetic field, its history, whether it has a big moon to steady its spin, whether it has plate tectonics to recycle its chemistry, on a dozen accidents of biography that we are only beginning to understand. So when someone tells you they have found Earth 2.0 because they found an Earth-sized rock in the Goldilocks zone, you should smile politely and remember Venus. Now let me take you to the worlds that have gotten everyone so excited lately, because the story gets stranger still, and the strangeness is instructive. Most of the stars in our galaxy are not like our sun. Our sun is actually on the large and bright side of the stellar population. The most common stars by far are red dwarfs. Small, cool, dim, red stars, burning slow and stingy, but burning for a very long time, trillions of years. And around some of these red dwarfs, we have found systems that make you catch your breath. There is one, a little star called TRAPPIST-1, only about 40 light-years away, which by cosmic standards is right next door. And around this one dim ember there are 7 planets. 7. all of them roughly the size of Earth, and several of them sit in the habitable zone. 7 Earth-sized worlds huddled around a single tiny star, orbiting so close that all 7 of them would fit comfortably inside the orbit of Mercury. If you stood on one of those worlds, the neighboring planets would loom in the sky larger than our moon looks to us, close enough to see their clouds, their continents, their weather. Imagine that sky. Imagine looking up and seeing another world hanging there, a whole world, close enough to make out its features. There is nothing like it in our solar system, and there is one even closer, around Proxima Centauri, the very nearest star to our sun, just over 4 light-years away, close enough that we can almost imagine sending something there someday. There is a planet in the habitable zone, the nearest possibly habitable world to Earth, and it is orbiting the closest star there is. If you were designing a universe to tantalize a curious species, you could hardly do better. But here is where it gets strange, and where my skeptic's discipline kicks back in, because I refuse to sell you the fantasy without the fine print. These red dwarf worlds have problems, big ones. Because the star is so cool and dim, a planet has to huddle in very close to stay warm enough for liquid water. And when a planet orbits that close, the star's gravity does something to it over millions of years. It locks it, tidally locks it, the way our moon is locked to Earth, always showing us the same face. So one side of that planet may face its star forever, in permanent scorching day, and the other side faces away into permanent frozen night, and the only comfortable place might be a thin ring of perpetual twilight in between. And worse, red dwarfs are violent in their youth and often stay temperamental. They belch out enormous flares, blasts of radiation that could strip a nearby planet's atmosphere away, or sterilize its surface, or both. So is a planet in the habitable zone of a red dwarf, a promising home, or an irradiated, half-frozen, half-broiled rock that lost its air 1 billion years ago? The honest answer, the only honest answer, is we do not know. We do not know yet. And I would rather stand here and tell you we do not know than hand you a comforting story that the next decade might humiliate. So how would we ever find out? We cannot fly there. Not in your lifetime, not in your grandchildren's lifetimes. 4 light years is a wall. So we are back to our old trick, the only trick we have ever really had. We are back to reading starlight. But now we ask it to do something almost unbelievable. When one of these planets transits, when it passes in front of its star and throws its shadow toward us, a little of the star's light does not just get blocked. A little of it passes through the thin ring of the planet's atmosphere on its way to us. It filters through the alien air. And every gas in that air, every molecule, absorbs light at its own particular colors, leaves its own particular fingerprints, dark lines etched into the rainbow of the starlight. So if you can catch that starlight and spread it out into its colors with enough precision, you can read, across trillions of miles, what that planet's atmosphere is made of. You can taste the air of a world you will never touch by reading the shadows in a rainbow. We are doing this now. We have built telescopes that can begin to do this. We are, at this very moment, sniffing the atmospheres of worlds around other stars. And here is where it gets strange in the deepest way, the way that touches on the oldest question we have. Because what are we looking for in that alien air? We are looking for a contradiction. We are looking for a chemistry that should not exist on its own. Take our own air. It is full of oxygen, more than 1/5 of it, oxygen. But oxygen is greedy. It is chemically desperate. It wants to react with everything. It wants to rust the iron and burn the carbon and bind up into stable compounds and disappear. Oxygen should not just sit there in an atmosphere for billions of years. Left alone, it would vanish. So why is our air full of it? Because something keeps making it. Something replenishes it, constantly, faster than the chemistry can remove it. And that something, on Earth, is life. It is plants and plankton, breathing out oxygen as fast as the rocks and the fires consume it, holding the atmosphere in a strange, unnatural disequilibrium. Our air is a lie that life tells the universe, and it has been telling it for billions of years. So if we look at a distant world and find its air is also holding an impossible mixture, oxygen alongside methane, say, 2 gases that should destroy each other, both present, both persisting, kept in that impossible balance by something continuously pumping them out, then we will have found not a planet, not a rock, but a biosphere, a living world. We will have detected life on another planet without ever leaving this one, by reading the color of its air. That is not science fiction. That is the actual scientific program of our era. That is what your generation may live to see. And now I have to slow us down, because I have been carrying you upward, and I have a responsibility not to lie to you at the summit. I have to tell you about the silence. Because there is another way to search for other worlds and other life, and it is the one closest to my own heart. Not just looking for microbes and green slime, but listening. Listening for a signal. For someone out there who is not just alive, but aware, and building, and broadcasting. Another mind looking back across the same dark. We have been listening, on and off, with radio telescopes, for decades, scanning the sky, sifting the static, hoping to catch one whisper of order in the noise, one signal that could only be artificial, one hello. And in all that time, in all that listening, we have heard nothing. Silence. A vast, patient, enormous silence. Now, what do you make of that silence? This is one of the sharpest questions in all of science, and I want to be very careful with you, because it is exactly the kind of question where our feelings try to hijack our reason. There is a famous line of thinking, we call it the Fermi paradox, after the physicist Enrico Fermi, who supposedly asked, over lunch one day, a simple and devastating question about the aliens. Where is everybody? If the galaxy is old, and it is, billions of years older than our sun, and if planets are everywhere, which we now know they are, and if even a tiny fraction of them bear life, and if even a tiny fraction of that life becomes intelligent and technological, then the galaxy should have been colonized, or at least filled with signals, many times over, long before we ever showed up. So where are they? Why is the sky silent? And people love to leap to an answer, because the silence is uncomfortable and they want it filled. Some leap to, we are alone. We are the only ones. It never happened anywhere else. Others leap to, they are everywhere. They are hiding. They are watching. They are visiting in the night. And I want to tell you that both of those leaps are the same intellectual sin. They are both people who cannot tolerate an open question, grabbing the nearest answer to make the discomfort stop. There is a piece of arithmetic I helped work on years ago with my friend Frank Drake that people call the Drake equation. And it is not really an equation that gives you an answer. It is an honest accounting of our ignorance. It says, to know how many civilizations we might hear from, you need to multiply together a chain of numbers. How many stars are born? What fraction have planets? We now know, almost all of them. How many of those planets are suitable for life? On how many does life actually begin? On how many of those does life become intelligent? On how many of those does intelligence build a technology that broadcasts? And then, the last number, the one that has haunted me for my entire life, the one I cannot stop thinking about. How long? How long does a technological civilization last, once it arises, before it falls silent? And it can fall silent in two ways. It can die out, or it can grow up. Here is the thing that keeps me awake, and I mean that literally. This is the thought that comes at 3 in the morning. We do not know that number, the lifetime of a civilization, because we have exactly one example, ourselves, and we have not finished the experiment. We do not yet know how long we last. And I have lived through a time when it looked entirely possible that the answer, for us, would be short. Very short. I have spent years of my life warning about the ways we could end our own story, whether by fouling our own air the way Venus did, or by something faster and more deliberate. And so when I look up at that silent sky, I do not hear an answer, but I hear a warning, and I hear a question about us. Maybe the sky is silent because life is rare. Or maybe the sky is silent because intelligence is common, but wisdom is not. And civilizations keep arising and keep destroying themselves before they learn to speak across the stars. Maybe the great silence is a graveyard. I do not know which it is. Nobody knows which it is. And I will not pretend to you that I do. Because the whole point, the entire point of everything I have ever tried to do, is that the honest not knowing is worth more than the comfortable lie. The silence is not empty of meaning. It may be the most important message we have never received. So let me bring you all the way back down now. Back down through the light years, back past the flaring red dwarfs and the 7 worlds of TRAPPIST-1 and the boiling gas giants and the frozen shadow of Mars, back down to where we started, on your patch of cold ground under the stars. Because I have saved the most important thing for last, and it is not out there. It is here. Some years ago, we had a spacecraft, Voyager, that had done its job and flown past the outer planets and was heading out of the solar system forever, out into the dark between the stars. And before it went silent, some of us asked for it to do one last thing. We asked it to turn its camera around, to look back. And from out beyond the orbit of Neptune, from billions of miles away, Voyager took a picture of the Earth. And in that picture, the Earth is not a majestic globe. It is not the blue marble you have seen. From that distance, the Earth is a single point of light, a pale blue dot, smaller than a single pixel, a mote of dust suspended in a sunbeam, so tiny and so alone that if you did not know to look for it, you would miss it entirely. And I want you to understand why that picture matters to the whole search we have been talking about tonight. Everything we are, everything we have ever been, every king and every peasant, every war fought over a scrap of that dot, every love story, every child, every saint and every monster, everyone you have ever heard of and everyone you never will, the entire human drama, all of it happened on that one pixel. Every other world we search for, every exoplanet, every distant Earth, from far enough away, is exactly that, a pale dot, a point of light in someone else's telescope. That is the humbling truth at the center of this whole enterprise. When we search the galaxy for another Earth, what we are really doing, whether we admit it or not, is trying to understand this Earth, learning how rare it is, or how common, learning how easily a living world is born, and how easily it dies. Every dead planet we find, every Venus, every Mars, every airless irradiated rock in a habitable zone that turned out to be a lie, is a lesson written in the sky about how narrow the path was that led to us, about how many ways there are for a world to fail, and how few ways there are for one to succeed and stay alive and wake up and start to wonder. So here is what I will leave you with, and I am not going to soften it, because you did not come here to be comforted. We are living in the first generation in the entire history of our species that can actually search. Not dream, not speculate, not tell each other stories around the fire, but search, with instruments, with rigor, with evidence, and get real answers back from the sky. Our great-grandparents did not know if a single other planet existed. Your grandchildren may know whether we are alone. That transformation is happening right now, in your lifetime, and most of it will be finished after mine. And the question at the end of it is not really, are they out there? The question, the one that should stick in your chest on the drive home tonight, is this. We have found that the universe is full of worlds, and that almost all of them are dead. We have found that being in the right place is not enough, that a living world is a fragile, improbable, knife-edge accident that can be lost. We are, at this moment, holding one, and we have not yet decided whether we are wise enough to keep it. So when you look up tonight and ask, is there anybody else out there? Ask yourself the harder question underneath it, the one the silence keeps asking us. If they were out there, and they were looking at their sky the way you are looking at yours, and asking the same question, and if their world went silent, the way so many of those worlds have gone silent, what was it that killed them? And are we doing it right now? That is the search. It was never only about them. It was always, from the very first night, a human being looked up and wondered about us.